Good afternoon, everyone. I'm going to stand behind the podium so that I don't make a cake of myself. Losing the microphone or falling off the podium here. So my presentation will be about something that none of you really wants to acknowledge, but all of us, it's an integral part of our lives. But it smells, it is dirty, and it might carry diseases, and we better not think about it. We flush it down the toilet, it's gone out of our lives, no worries anymore. However, it does contain lots of information about yourselves, what you've eaten, what your state of mind might have been. Like my feces probably tomorrow will have lots of stress hormones. So that's what I'm going to talk about today. If you're wondering what this picture is, it's a very valuable picture. It's a picture of one of the rarest African mammals, the black rhino, and it's taking a shit, something that you don't necessarily see in the wild. Like you probably won't even see the rhino. So what do researchers, or not even researchers, scientists, veterinarians, people working at zoological institutions, rehabilitation institutions, and so on do when we need to get information from animals? Typically, we have to restrain an animal, for example, using our hands, or we have like funny contraptions that we can hang the animal in or restrain in a different way. And in wild animals and dangerous animals, we usually have to sedate them. Like here, this leopard, or also the rhino. This is a white rhino, not a black rhino. And we can get lots of information from that, but it's also very stressful for the animal. It's stressful for us, especially if you work with quite big and dangerous animals. And it's stressful for the animal and very dangerous for the animal and also for us. So if we want to measure hormones, for example, we often don't want to just have one sample. We want several samples from the same animal. So this would need to be repeated, causing more stress and being more dangerous to us and the animals. Sorry. So researchers came up with other methods of measuring hormones. And there's just some examples. So you can use hair, for example, which is great if you can find it somewhere in the woods. Otherwise, you also have to capture the animal and cut off the hair. The same goes for urine. Urine, you have to get somehow before it just disappears into the soil. And also saliva, like in this Komodo dragon. I'm sure you don't really want to face the Komodo dragon several times in a week to get its saliva. Another really interesting thing that people have used is baleen from whales, baleen whales, which basically the teeth. And yeah, but there, you have to be very brave to go out and actually capture a whale and then cut off its baleen. Do you really think that people have done that? Probably not. Usually they've used baleen from dead specimens or museum samples they got. All of these, you somehow have to get to the animal, but there's one great thing that animals just leave there for you to take, and that's their feces. So there's just some great examples of feces. There are also other animals that really love feces, and you have to be a bit faster than them to get your samples. So there are these dung beetles, and there's also other information you can get, of course, from feces, and that would, for example, be their diet. Parasites like worms you can find in the feces as well. But for what I'm really interested in is how we can measure hormones in feces. Oops, sorry, that was one too far. So we're back to the black rhino. It's one of those very rare species. We want to breed them to increase their populations, and that is often being done in zoos because it's very difficult in the wild. And also there are problems there with poaching, for example, so it gets very expensive. And you need to look into how can we do that. And it's not actually as easy as just putting a male and a female together. Unfortunately, that often does not result in little baby rhinos. And you need methods to determine when, for example, a female is receptive or when a male has enough sperm and testosterone to be able to father a baby. And that you can see, do measuring hormones in feces. And fecal hormones have been used to determine pregnancy in black rhino, to look at the cycle of the females, and also when is the best time to introduce the males and the females together, because black rhinos are solitary, so they don't live in family groups or so there are specific times when the male and the female need to come together. And then, of course, you also need to capture those animals. You have to get them to new facilities or so, and you want to know how stressful is that actually for these rhinos. Another species that is also very rare, it's a cheetah, and very similarly to the rhino, you also want to know how can I breed them in captivity. And again, it's not as easy as just putting a male and a female together. In that case, it seems the age matters, the age of when you put a male and the female together. And also the problem is pseudopregnancies. So pseudopregnancy is when a female has a behaviors and just looks like she is pregnant, but in fact she's not pregnant. So you might think, oh great, it has worked, and then no babies result from that. So you want to know if she's pregnant or just pseudo-pregnant, for example. So people have looked at that using fecal hormones. You also might want to look at when is a male going into puberty, so when will you be able to breed with him? And of course, a big part of breeding is when they're stressed, they're not going to breed. So you want to see how different way, like if you have them in a zoo, for example, if there are people, how does it affect them versus if you have them in the background, for example. Okay, and this is not a rare species at all. The laboratory mouse, there are probably millions or even billions of them all over the world. And it's the main species that main mammal most people work on in biomedical research and many other areas. And for most part, people still use blood. They restrain the animal because it's easy, it's quick. But there are some that have started using feces, and there are a few studies. And the primary thing is looking at, are they stressed during specific experimental procedures? So for example, in tumor research. But the main thing is to look at, is there a problem with how we keep them? Are there better ways of keeping them that's less stressful for them? How, what affects their, how we are handling them, how we are marking them, and so on. So the feces have been used for those types of research in the laboratory mouse. So don't worry too much about the entire slide. I actually just want to indicate the two main areas that we use feces for. And you can already guess from what I told you, it's primarily stress, just here on the left, and reproduction on the right. And the hormones we measure in the blood specifically is cortisol and corticosteroids for research into stress, and estrogen, progesterone in females for reproduction, and testosterone in males. Unfortunately, there are some problems with using feces in that the hormones are digested and you can only measure hormone metabolites. So you need to validate those assays, and you do that, for example, by stressing an animal or by injecting one of these things that then increase metabolites in the feces. And that's what we did in the elephant shrew, this cute little mammal here. And you can see that before we stress them, the levels are very low, whereas in females it increases, and it increases a little bit in males, but not as much. But we do see an increase here, for example, in this one individual. And this is very interesting, as it might indicate that females are actually more stressed in the species. So what does it mean? We can use this now for learning more about these animals, but also for working on endangered species like this gray-faced Zengi here, and find out more about them, and also maybe breed them in captivity. And I just want to also thank this. So I did the work in South Africa at the University of Pretoria, and there's some people that are or were involved in this research.